Hi guys, welcome to our last episode of physics past paper. Okay, so again we are doing this 0625, okay, paper 21 October November 2020. Okay, by the way, this video is sponsored by Che. Okay, so Che aims to help all the students to solve any questions that you guys face in your study. Okay, so feel free to check them out. At the same time, this video is also sponsored by VBAS Malaysia. Okay, so VBAS is a tutorial center in Malaysia, so we aim to help students to excel further in their studies. Okay, so without further ado, let's look at the question. Okay, we have done questions Q1 to 26. So today we are gonna move on from 27 all the way finishing this paper. Okay, let's look at question 27. Okay, a piece of steel is slightly magnetized. Okay, remember, yeah, steel we call it as a hard magnetic object. Okay, what do you mean by hard magnetic? So hard magnetic, right? Okay, they can be permanently magnetized here. Okay, after that, you hit it several times with its magnet. Okay, so at first, you make it a permanent magnet. So after that, you smash it with a hammer. So what happens is that it loses its magnetism. So yes, it becomes a strong magnet. After that, it loses its magnetism. Remember, you don't strike a magnet with hammer because reason why the magnet loses its magnetism. Okay, next, two soft iron pins are suspended from S pole of a magnet. Okay, which diagram shows how the pin are deflected? Okay, so as what you know, this is how the magnetic field come join in, right? Can you see that this is how the magnetic field come in? Okay, from north to south. Okay, so this is how the magnetic field around the magnet. Okay, so this is definitely wrong. Okay, this is not quite right. And this is even weirder. Do you see that? Oh my god, how can you have one straight but another slanted? That just doesn't make sense, right? So the answer is C. Okay, straightforward. Okay, let's move on to 29. A negatively charged plastic rod. Okay, right now you have this negatively charged plastic rod. Okay, is brought close to an uncharged metal sphere and held there. Okay, what happened when the metal sphere is Earth? Okay, so what happened is that, imagine you have this charged rod, okay, and you bring it to Earth. Imagine you bring it to Earth, and what will happen is that the electron will be directed towards the Earth. So the electron will just move towards the Earth. Okay, so you can see that electrons flow from the metal sphere to Earth. Yes, it's possible. Okay, electron flow from metal Earth, that is not possible unless you put a positively charged plate here, then electron will be drawn. But you don't have any positively charged rod here, right? So B is not quite right. Positive charge, remember, yeah, guys, positive charge will never flow. Okay, positive is basically your proton will never flow, yeah. Okay, so please remember that. Okay, next 30. Which statement define the electromotive force? Okay, electromotive force, it's basically the total potential difference supplied, okay, by the cell itself to drive the charge along the circuit. Okay, so it's basically the current in the cell. Nah, that's not right. As what I mentioned, it's basically an energy, right? An energy to drive all the charge around the circuit. Okay, so current, the moment you see current, that's not quite right. Okay, so the energy supplied by the cell to drive 1 coulomb of charge around the complete circuit. Yes, that fit my explanation, right? To drive 1 ampere of current, no, to drive charge, remember, yeah? Okay, the formula, right, it's E is equals to VQ, yeah? Okay, so 30, answer is C. Okay, 31, 4 vials are made from the same metals. Okay, right now you have the same metals here. Okay, greatest resistance. Okay, still remember what is the factor affecting resistance. Okay, let's look at the factors. Okay, what do we have? The first one, you just imagine, right, resistance is basically how bad a traffic jam is. Okay, how bad a traffic jam inside the wire. Okay, so The moment if you increase the temperature, imagine during a hot day, like everyone on the road is so dizzy, so tired, they just don't feel like driving. So traffic jam will be very bad, very terrible. Okay, so your resistance will also go up here. Okay, what else? You just imagine, right, if you have a very broad highway, okay, so if your surface area is very broad, imagine you have a large highway, huge highway, okay, your traffic jam is gonna be not that terrible. So resistance drop when surface area increases. The same thing, let's say this route, right, is very lengthy, okay, it's very long, okay, what will happen is that it also leads to an increase in the resistance. Okay, so I definitely need to look at a long wire. 10 cm is way too short, so C and D is out of the option. 100 cm long, it's okay. Okay, and diameter, I need to make it as small as possible because the smaller the road, just imagine, okay, you have a very small road and you have a lot of cars, so all the car will just get jammed, will just get stuck in the road, right? Okay, so that's what happened. So 31 is A, cool. Okay, so 32, which circuit is just a single lamp lit? Just a single lamp lit, yeah. Okay, so what's your answer? Let's look at this part. So at first, this light, okay, this allowed one current flow, right? Okay, allowed here, this light, and at the same time, this also light, right? So these two will glow. Okay, so this is not quite right. Okay, what about B? Let's look at B. So can you see that? Oh my God, there's no way this current can flow, right? So there's no flow here. So eventually, none of this will light. Okay, B is out of the option. Okay, what about this? Okay, so can you see that it cannot go through here? So it must go here and this will glow. And eventually the current just return. So this is how the current will flow like. Okay, so this will glow and only one glow. Yes, your answer is C. Okay, what about D then? Okay, again, can you see that this diode, right? Diode only allow one direction current flow. Can you see that this diode direction, it prohibits the flow of current, so current is not able to pass through it. So this will not glow, yeah. Okay, I think quite easy, right? Nothing difficult. Okay, let's move on to question 33. Okay, student use 4 ammeter. Okay, guys, remember, yeah, whenever you are using ammeter must be connected in a series here. Okay, what do you mean by series? Series as in they must be side by side. Okay, to measure the current in different part of the circuit shown. Okay, which 2 ammeter read the largest current? Okay, guys, remember that in a parallel circuit, okay, let's say if you have a parallel, right? Okay, your I total, it's basically the biggest. Okay, so the I total is made up of I1 plus I2 plus I3. So that will be your I total. Okay, so this might be your I1, this might be your I2. These two add together will give you your I total. So these two are your I total. Okay, so P and Q will actually produce the largest reading. Okay, if you cannot visualize it, you just imagine, right, you are driving. Okay, so when you reach a junction, what will happen? All the cars, imagine you have a lot of cars here. So what happens is that if you reach a junction, some car will turn to the right, some car will go straight. Okay, so eventually the number of cars just decrease over time, right? But let's say if 2 junction connect, can you see that all the cars gather again? Oh my God, the total number of cars is so huge right now. Okay, get it, right? Okay, next, 34. Okay, logic gate right now. Okay, give the truth table shown. So let's say if you have all these logic gate. Okay, so by the way, let's label everything. This one is OR gate. This is a NOT gate. This is an AND gate, NOT gate. This is a NAND gate and a NOT gate. And this is a NOR gate and a NOT gate. Am I right? Okay, so if I pass through 0, 0, it does return a 1. Okay, let's try it out here. Yeah, 0, 0 will return 0 here, 0 return 1 here. Okay, so this does make sense. Let's say if I put 0, 1, it will return 1 here, then 1 not will be 0. Okay, so this out already because, okay, I put first, second, third, and fourth. Okay, so the second is out. So A is not your answer. Okay, let's try another one. 0, 0 is 0, 0 and 1. 0 after a NOT gate is 1. This is correct. 0 and 1 will give you 0. 0 NOT is 1. This is correct as well. 1 and 0 will still give you 0. 0 will turn into 1. Correct. 1 and 1 will turn into 1, and 1 NOT gate will turn into 0. Wow, perfect. So the answer is B. Okay, that's it. Clear, yeah? Okay, what about NAND gate? Okay, for NAND gate, let's say if you get 0, 0 here, okay, instead of getting a 0, it will be 1. So 1 will turn into a 0. The first statement is already wrong, okay? So what about NOR gate? NOR gate, 0, 0 will also give you a 1. Okay, that 1 will turn into 0. This is wrong as well. So C and D, the first option is already wrong. So you don't need to look further. Okay, cool, yeah? Okay, 35, the transformer. Okay, what transformer is used for? We have two different types of transformer. We have a step-up transformer to increase the voltage output, or step-down transformer to decrease the voltage output. Okay, so you have step-up and step-down, yeah? Get out of my head. Sorry, I'm a bit high. Okay, so for step-up transformer, remember, is to step up using up. So you increase the voltage. Okay, how do they increase the voltage? They have higher number of coil. Okay, in the secondary. Okay, for step down is to decrease the voltage. At the same time, they have very little number of coil in the secondary. Okay, judging from here, right, this is definitely a step up. Am I right? Okay, so step up, as what I mentioned, can you see that your your voltage is way greater, right? So it is a step up. And at the same time, okay, this is your secondary coil. So secondary coil you need to have more secondary coil. Okay, so this does make sense. This does make sense. This doesn't make sense. So C is out of the option. Okay, let's perform the calculation. For the formula wise, is NP over NS is equals to VP over VS. Okay, so NP over NS, from this diagram, your primary is 240, your secondary is 4,800. Okay, give me a second, let me get my calculator. And if we were to calculate it, 240 divided by 4,800, I'm getting 1 over 20. Okay, so my VP divided by VS must be 1 over 20. 50 divided by 1,000. Your answer is 1 over 40. 1 over 20. This is right already. Okay, so let's work out the other one. This is 1 over 200. And again, this is a step down, so this is wrong. Okay, so my answer is A. Okay, straightforward, right? As you can see, physics paper is not actually very hard. Okay, next. The diagram show part of a long current carrying conductor. Okay, at which point the magnetic field is the strongest. It's quite easy, right? The closer it is to the wire, the stronger it is, right? Okay, so I just put it here. The closer it is to the wire, the stronger it is. Without a doubt, right? Okay, without a doubt, I know that the answer is C. Okay, so cool, yeah? Okay, let's look at 37. A beam particles move through a magnetic field. In which situation does magnetic particle experience a magnetic force? Okay, a particle experience a magnetic force. Okay, you know that alpha particle is basically a positive charge. Okay, so a beam of alpha particle move parallel. It won't move parallel. Reason being, as what I mentioned, alpha particle will react to a magnetic field, right? So 37A is not quite right. A beam of electron moving parallel, as what I mentioned, electron has a charge. How can electron move parallel? They will react to your magnetic field, right? A beam of beta particle move perpendicular. Yes, because they do react towards your magnetic field, right? It's charged particle anyway. Okay, by the way, what is beta particle? Beta particle is just an electron, a high-speed electron, okay? Gamma is a ray, so gamma has no charge at all. Okay, next, a beam of neutron moving as what? This neutron should move parallel, my dear, because neutron, it has no charge. So your answer is straightforward, a C. Oh my God, my C is so ugly. Okay, next, which statement is correct for the nucleus of any atoms? Okay, for nucleus of any atoms, okay, nucleus consists of just neutron and proton. Yeah, remember electron is surrounding your nucleus. Electron is constantly moving around, okay, revolving around your nucleus. Yeah, example, just imagine it like a solar system. Sun is basically nucleus. Earth, Jupiter, Mars, everything is your electron. Okay, so one is wrong. The nucleus contains same number of proton and not necessary. Okay, sometimes neutron might be more, sometimes neutron might be less. Okay, so there's no fixed statement saying that proton and neutron must be same. No. Okay, so if you take chemistry, you should know you can calculate your neutron number by looking at the periodic table. Yeah. Okay, let's look at C. The nucleus has a total charge of 0. Remember, yeah, guys, nucleus has a positive charge. Yeah. Okay, nucleus is very small. Yes, correct. Remember, yeah, guys, nucleus is very dense. It is very dense. Okay, so the answer is D. Okay, next, two beam of radiation, P and Q, enter the electric field as shown. Electric field this time, yeah. Okay, can you see that P gets attracted towards a positive plate. So what it tells you, okay, P must be negative. Okay, negative is basically a beta. As what I mentioned, beta it's an electron, a high-speed electron. Alpha is basically a 4-2 helium, which is a positive charge. And your gamma is just a ray. Gamma has no charge yet. So let's say if I put gamma will just go straight through. Yeah. Okay, go straight through without any interference by your positive or negative charge plate. Okay, so P, I know that it's beta, so C and D is out. Okay, as what I mentioned, it will never be a gamma, so the answer is A, alpha. Okay, next, beta decay. As what I mentioned, the moment you see this word beta, okay, the first thing that must come in your mind is that beta, it's basically a high-speed electron, okay? A high-speed electron. Okay, so for this high-speed electron, the moment any radioactive isotope undergo beta decay, they produce an electron. Electron is basically a 0, -1. So everything has a 0, -1. Okay, cool. Okay, but do you see that this is not producing, right? My statement about emission is it produce a high-speed electron. This is reacting. Produce should be somewhere here. So A and B is out of the option. Reason being this statement is not right. Okay, next, you just need to add them up. 209, 2090. Yes, it does make sense. 82, 83 minus 1. Yes, this does make sense. However, you look at this, 209 plus 0 is 209, correct? 81 plus minus 1 is 80, and that's not 80, that's 82. So this is not right. Okay, so your answer is C. So with that said, okay, we have completed this paper. Okay, so October, November 2020. Okay, I hope you guys find this video helpful. So if you guys have any questions, feel free to leave it in the comment section below. So if you have any further questions, so feel free to visit to the website that I've just mentioned. Okay, so or you can drop a comment regarding what are the papers that you guys need help so that I can make a video to discuss about the papers. Okay, so that's all for today and hope you guys find this video helpful. So please feel free to like and comment or even subscribe to our channel. Okay, thank you very much and see you guys. Bye.